Welcome to another episode of the Efficiency and Reliability Podcast. Today we'll be discussing the challenges of furnace efficiency loss caused by fouling in ethylene plants and how advanced technologies can help address this issue. Ethylene and propylene are precursors to many chemicals, fibers, and plastics used in daily life. At most petrochemical sites, the ethylene or pyrolysis plant feeds downstream units. The heart of the ethylene plant is a system of furnaces where thermal cracking occurs. These furnaces consume significant energy and need maintenance due to potential coke formation inside radiant tubes. Frequent shutdowns for decoking or maintenance are costly and disrupt production. Steam cracking or pyrolysis is a non-catalytic process requiring heat to initiate and sustain reactions. The cracked gas contains hydrogen, methane, olefins, target products, diolefins, acetylenes, naphthenes, aromatics, and tars. Four main parameters determine ethylene or propylene yields coil outlet: temperature 820 to 870 degrees Celsius, hydrocarbon partial pressures, low pressure favors selectivity, residence time short RT favors selectivity, and heat flux distribution in the radiant section. Lower uniform flux favors run length. Fouling of the convection section leads to lower RS inlet temperature, requiring increased radiant heat flux. This increases coke deposition and shortens run length. A cracking furnace is divided into three zones: the radiant section, convection section, and transfer line exchangers, TLEs. TLEs are vertically placed with cracked gas in the inner pipe and boiler water steam in the outer pipe. These waste heat boilers, WHB, rapidly cool the cracked gas to prevent secondary reactions while producing saturated VHP steam. Radiant section of the firebox is a rectangular refractory line space where the radiant coils are suspended vertically, firing from the bottom. The SRT, or short residence time coils, favor ethylene production. Two fireboxes share a common convection section, meaning its performance affects both radiant chambers. Convection section located above the fireboxes. The convection section includes mixed feed preheater, or MFPHI, economizer, or ECO. Cold high-pressure steam superheater, or CHPSSH, hot high-pressure steam superheater, or HHPSSH, mixed feed preheater, or MFPH2. Over the last 6 years in operation before cleaning, the stack temperature rose from 190 degrees Celsius to 230 degrees Celsius, equaling 2.0% losses in fuel efficiency. The purpose of this project was to reinstate the overall fuel efficiency, save fuel, and cut emissions. Unfortunately, windows in the convection section were not designed to provide access to any type of fouling removal equipment. The ethylene furnace reached out to IGS, and IGS suggested using a unique remotely operated vehicle, or ROV, fouling removal technology. New access openings were created to enable placing an ROV on top of each convection bundle. The radiant box has been isolated. All effluent and debris after fouling removal have been collected and displaced to the ground level in sediment containers. By utilizing ROV technology, the furnace achieved complete fouling removal from the convection bank coils and over 90% removal from all convection bundles with no damage to the refractory due to the ROV's precise high-pressure application. This resulted in a 40 degrees Celsius drop in stack temperature, a 2 percentage point increase in overall fuel efficiency, and a payback period of less than 4 months, all accomplished within 4 by 12-hour shifts. Acknowledging the impact of the cleaning, heat distribution between CS and RS remains crucial in coking-sensitive services. Keeping the convection section surface clean helps save fuel, increases steam generation, and positively influences the steam cracking process. The achieved benefit was approximately 16,000 megawatt hours per year in fuel savings, and a 2,500 ton annual CO2 reduction. Fuel is a methane-hydrogen mixture. Due to the higher crossover temperature radiant inlet temperature, the residence time will be slightly less, with an additional opportunity to make more ethylene due to enhanced selectivity. After almost 2 years in 2022, the client reported a slight elevation in stack temperature of 10 degrees Celsius and a stable efficiency increase of 1.5 percentage points. The client was pleased with the achieved result and has since conducted tube tech defouling as a preemptive measure in 2023 in the sister unit and plans to return to the first unit in 2024. To ensure the benefits are long-lasting, IGS also recommends combining the tube tech ROV cleaning with CTEC's proprietary ceramic refractory coatings to protect and encapsulate the ceramic fiber, preventing refractory deterioration and new fouling formation on the outside surface of the convection tubes. And that's it for today's episode. If you found this case study interesting or helpful, you can read more of them on our website, www.integratedglobal.com. Don't forget to share, and subscribe to this podcast. As always, this is your host, John.